Okay, so I wanted to make this video to help you out with the post lab. If you didn't get one of these, again, I sincerely apologize. I don't know where all my copies went, but I have posted another one for you on Schoology, and I have extra in my classroom. So what we're doing here is I followed a stepwise procedure to help you solve for the percent of copper that is in your original sample. And this percent copper will tell you what percent by mass of copper is in your brass. So what you did on the first day of this experiment was you created a calibration curve by first setting the absorbance of your machine, and then you plotted all your different concentrations and read the absorbance of these concentrations until you made a linear line. This linear line tells you how your concentration changes the absorbance. So as your concentration goes up, how does your absorbance go up? So your y-axis represents absorbance, and your x-axis represents molarity. So your slope is absorbance over molarity. Your y in the equation is absorbance, and your x in the equation is molarity. The absorbance of your diluted copper sample, I took 5 milliliters of your concentrated sample, and I added 25 milliliters to make a 30 milliliter dilution. This is called a 1:6 dilution. I took 5 milliliters and I made 30 milliliters of it, and this is your diluted sample. This is what you read today in the absorbance spec. So because absorbance is in your y-axis, your absorbance will be plugged into the y in your y equals mx plus b equation. And this is some sample data. So I saw the machine read 0.113. That is my absorbance of my diluted copper sample. The concentration of my diluted sample can be solved using this y equals mx plus b equation. Y represents absorbance, x represents concentration, so all I need to do is plug it into this equation. Y is my absorbance, which was 0.113, and then I just plug in the rest of the equation that I generated for you on that Excel spreadsheet. Okay, so then it says how many moles were in your diluted copper sample. So here's X. I need to find concentration first, and then I can go to moles. So 0.113 minus 0.0134 divided by 1.6574. My diluted sample was 0.060 molar. My diluted sample was 30 milliliters. So 30 liters, or sorry, 0.03 liters times my concentration would give me moles. So I got 1.8 times 10 to the negative third moles of copper in my diluted sample, so the sample that I made for you today in class. To figure out how many moles are in my concentrated sample, I could use this moles that came from my 5 milliliters and figure that out, or I can do M1V1 equals M2V2. These should be the same. When I diluted your sample, I took the moles of this 5 milliliters and put it in 30 mils of water. I did not add 30 mils of copper 2 sulfate or copper ions. It was only water. So all of my copper ions came from these 5 milliliters, which means I have 1.8 times 10 to the negative third moles in 5 milliliters. But my concentrated sample that you made, you dissolved brass into 15 milliliters. I only took out 5 milliliters to dilute it for you. You had 15 milliliters to start with. So I took out a third of your sample, which means this is only a third of your copper ions. So I need to multiply this by 3, and that's how many copper ions were in your 15 milliliter concentrated sample. So again, I took out 5 milliliters. I diluted it to 30 milliliters. You read the concentration, read the absorbance to get you the concentration of the diluted sample. You found out how many moles that was. Your moles of copper came straight from these 5 milliliters. Moles of copper in these 5 milliliters need to be multiplied by 3 because I only took out a third of your sample. You made a 15 milliliter solution. I only take out a third of it. So this only represents a third of your copper ions in that solution. So this is 0.0054 moles of copper ions. So now that I know how many moles were dissolved in your 15 milliliter sample, I can figure out the mass of that. So 0.0054 moles of copper ions. For every 1 mole of copper, it weighs 63.55 grams. So 0.343 grams of copper was in your 15 milliliter sample. So the mass of my brass pellet, yours is probably close to mine, is 0.49 grams. If I have 0.343 of those grams that are copper, and 0.49 of them, or sorry, 0.49 grams is the total mass of my pellet, this will tell me what percent of my pellet is made of copper. So I got 70.0%, which is pretty close to the actual value. I do not care what this number is. I care that you understand these steps in solving this problem. So again, please look through these steps, use it to help solve, and download this paper, or you can even come pick one up after school of this worksheet that will help you step through it.